Supercapacitors versus batteries. Welcome to this presentation on supercapacitors versus batteries. Today, we'll explore their key differences, advantages, and applications. What is a battery? A battery is a device that stores chemical energy and converts it into electrical energy when needed. Common types of batteries include lead-acid, lithium-ion, and nickel-cadmium. Batteries rely on chemical reactions within their cells to store and release energy. This makes them ideal for long-term energy storage applications where slow, steady discharge is acceptable. What is a supercapacitor? A supercapacitor, also called an ultracapacitor, stores energy differently, using electric fields rather than chemical reactions. It consists of two conductive plates separated by an electrolyte. Supercapacitors are characterized by very high power density and extremely fast charge and discharge cycles. They are well suited for applications that require quick bursts of energy. Comparison table. Let's compare batteries and supercapacitors across key features. Batteries store energy through chemical reactions, offering high energy density in the range of 100 to 265 watt-hours per kilogram, but with low power density. Their charge and discharge processes are relatively slow, typically taking minutes to hours, and they generally last for about 500 to 1000 cycles. On the other hand, supercapacitors store energy electrostatically, providing low energy density around 5 to 10 Wh/kg but very high power density, up to 10 kilowatts per kilogram. They can charge and discharge in seconds and have a lifespan exceeding 1 million cycles, though at a higher cost per unit energy stored. Applications of batteries. Batteries are widely used in everyday electronics such as smartphones and laptops, as well as in electric vehicles and solar energy storage systems. They also provide backup power for uninterruptible power supplies, helping to maintain operations during outages. Applications of supercapacitors. Supercapacitors are ideal in scenarios requiring rapid energy discharge. One prominent application is regenerative braking in electric vehicles, where the energy generated during braking is quickly stored and reused. They also serve as backup power for memory in electronic devices, stabilize power grids, and support industrial machinery that demands sudden energy bursts. Advantages and disadvantages. Batteries have high energy density, are cost-effective, and represent well-established technology. However, they suffer from slower charging, shorter lifespan, and environmental concerns due to chemical waste. Supercapacitors offer fast charging and discharging, extremely long life, and perform well across a wide temperature range. But they have low energy density and are relatively more expensive. Conclusion. In conclusion, batteries are best for applications requiring long-term energy storage, while supercapacitors are preferred where rapid energy charge and discharge cycles are critical. Hybrid systems that combine both technologies are emerging, offering the best of both worlds, high energy density and rapid power delivery. Thank you. Thank you for your attention. For any further questions, feel free to reach out at your contact information.